Right, we're going to just have a look at function composition in this lesson. So basically composition is when you take one function and then sort of apply a second function to it. So you can think of it as just like a function of a function, or you could think of it as like input output. So you put in an input to get a first output, and then you use that output as the input of the next function. Either way is fine. A couple of different ways that we write functions. If we have this h, which is the composition of f with g, don't worry too much about the ordering of like which one's with the other. But the two ways that we can write it and actually have the same thing are this g circle for composition f, so that's g composed with f, or you can write it with the x in the notation. So h of x is g of, and then what you see is f of x in here. And that one actually is kind of nice because it sort of indicates exactly how you generate functions through composition is you literally plug one function, f, into the other function, g. So we'll start by looking at this example here of two explicit functions, and we're going to evaluate g of f of 3. We'll do this two ways. Let's write the first method. One way that we could do this is just sort of track 3 and think of it as input outputs. So g composed with f of 3. So that's, if we use the other notation, that's the exact same thing as g of f of 3. And so what we would do first is just simply evaluate f of 3. So I could do that. F of 3, so if I follow my rule, is 2 to the power of 3, and that's 8. So easy enough. And so then what we're going to do now is plug this into g. Plug f of 3 into g. And so what we're going to get is g of 8. And then we follow the rule for g, so that's 3x plus 1, so that's 3 times 8 plus 1, that's 24 plus 1 is 25. So that's one method that we could use to do it. We get that answer 25. The second method, what we can actually do is just actually construct this new g composed with f function. Yeah, so I'm going to construct g composed with f, and I'm going to do that by plugging f into g. So g composed with f of x is g of f of x. And I know what f of x is. It's 2 to the x. Right, those things are equal. And now we do what we were talking about before with plugging things in the function. I'm going to replace the x in g with 2 to the x. Right, so g to the x is 3x plus 1 with this 2 to the x. So it's just that x. And so that's going to be 3. And instead of instead of x, it becomes 2 to the x, and then plus 1. So like this. Now be really careful. It's not at all the same thing. This is not 6 to the x, right? That 3 is not in the exponent, so just be careful of that. You just have to leave it 3 times 2 to the x. And then what we would do now is now we can plug in the number 3. And so now if I want to get g composed with f of 3, I will get g of f of 3, so that's 3. I've got my rule, it's right here, 3 times 2 to the 3 plus 1. And then you'll see kind of falling into place. It's exactly what we did on the left now. It's 3 times 8 plus 1 is 24 plus 1 is 25. So I think the method on the right is possibly a little bit more work than the method on the left. But this one can be used kind of in all situations, because I might not ask you to evaluate a composition at a particular value. I might actually just ask you to find the composition. And that's the first 3 steps of what I did there. I found the composition and then plugged something in. So we actually came up with more results on the right-hand side, because now I can really quickly evaluate G composed with F at all sorts of other values. So I did a little bit more there. We'll just look at what we do when we encounter some of these in other scenarios, so like tables of values and graphs. So let's say F is going to be this collection of points, 2 and 1, 4 and 3, let's say 6 and -1. And G is going to be another collection of points, and let's say -1 and 3, 1 and 5, and let's say 3 and how about I go with 2? Great. So what I'm going to do, I'm going to try to get 2 things here. Let's go with, yeah, I'm not really going to be able to get a rule for this composition. I could actually create it as a list of points and just see where it's possible. But typically what you'd be asked to do for these types of questions is to find, let's say, let's do a G of F of 4. And then maybe I'll try a different one. Let's try going the other way. Maybe F of G. Let's try 1. Okay. Just to see what happens here. All right. So for G of F of 4, what we're going to do is just have a look at the graph. I can see right here, this point says that F of 4 is 3. So I should be able to actually just plug that in to get G of 3. And then I can go maybe a little further. And I know G of 3, according to this point, is 2. So I can plug that one in and I get my output of 2. So not too bad. All right, let's see what happens on the next one. I know that G of 1 is 5. So I'll plug that in. And then what you'll notice is I don't have an F of 5. There is no F of 5. I don't have an output for 5, so it doesn't exist. Nope, didn't spell that right. So yeah, that one doesn't exist, and that's basically how we'd answer that. So you could go through and look at, for example, if I wanted to find the entire function, G composed with F, I would basically look at what 2 does. 2 goes to 1, 1 goes to 5, so 2 would go to 5. 4 goes to 3, which goes to 2, so 4 goes to 2. And 6 goes to -1, which -1 would go to 3. And so I'd actually have a collection of 3 points. But you notice that G doesn't go back to F quite as nicely because I didn't design it to. I didn't make it sort of go back and forth very well. You just list the points that exist, basically. All right, I'll do one last one. Just do a quick graphing one. That's not the color I wanted. I'm not going to make this a particularly interesting collection of functions here. So let's say that we get a blue one, and then maybe I'll have a green function that looks like this. So just a couple of what we'll talk about soon, piecewise functions. It just means that we can break it up into nice little equation pieces, which we can do for these. So let's call the blue one g of x and the green one f of x. And yeah, so let's evaluate. Let's try to make sure I don't do anything too wacky here. F of g of, let's say, 2. And g of f of, let's say, -4. Yeah, and it's really going to be the same idea as looking at those collections of points. We just sort of translate, like remember, this is a whole bunch of points. It's just not a clean list. We just translate the points to the function notation. So for the first one, I'll just have a look. I'm going to do f of g of 2. So g of 2, I can look at the graph here and see that when x is 2, we get an output of -1. So this here states that g of 2 is -1. And so what I'll get, I'm going to just rewrite it so we can see this a little better. So that's going to be f of -1. And then I'm going to look at the -1x value and put that on f. And so I can see I get this point here, and this tells me that f of -1 is 3. So that's my first answer. And then for the other one, I'm going to have g of f of -4. So I'm going to do the same thing. I'll just use a different color. Let's go with, I guess, green. Nope. Let's try pink. Don't have anything like that in there. Oh yeah, so I'll start by finding f of -4. So when x is -4, I get this point here at, again, 3. So this will be g of 3. And I just find what g of 3 is. Yeah, it looks like it'll be right there. So g of 3 is -2. And so that's my composed output. Yeah, so actually doing compositions is, maybe takes a little getting used to when you're dealing with the graphs and the points, but when you're actually given the functions, it's just plug one inside the other. So you just really need a bit of practice with putting things in the right place, and that should pretty much do it for you.